Hey, I've been thinking. You and I have known each other for quite a while, and I think it's time we connect. Our habitats together. Today's video is going to discuss edge habitat, habitat connections, and wildlife corridors. So, I have been looking at Google Trends, and I saw a lot of people ask a question in Google that was, which of the following is an example of a wildlife corridor? So, of course, this is someone's AP test, this is someone's exam that they want to, get the answer for without actually doing any of the background work. And I hope that you passed. If you found this video because I'm using Google search trends and this pops up because I'm going to put that exact question into my tags on here, hi, welcome. This video is going to cover everything you need to know. So, I'll be very frank that a lot of the stats, figures, and different understandings of wildlife crossings, wildlife habitat, is from this. This is an awesome report that was published in May of 2021 from the USDA and the US Forest Service that covers a lot of different elements about highway crossings. And this is, of course, linked down in the description. Every source that we talk about today is down in the description down below. But let's first take a second to actually talk about the issue at hand here. This may be kind of review for a lot of people, but hey, let's spend some time to talk about it. So, what is the actual issue that we are trying to convey here? Well, we have habitat. We have had habitat for a long time. Say this giant green blob represents a piece of beautiful forest habitat. Okay, now, all habitat has something called edge effects, and the edges of habitats undergo a different set of ecological principles, okay? It has been found through various studies that the edges of habitats can have microclimate differences up to about 100 meters into the forest. So I'm going to draw a blue line in here. Now, anything between the blue and the green we will consider as edge habitat, okay? This is just visual. This is, of course, not done to scale, nor is it consistent. Now, in this edge, what happens is a wide array of different effects. We imagine this is a forest, right? And say wind is coming through. Well, the wind will hit the edge, and then it will actually dissipate due to the various trees that are there, the various plants that are blocking it. It will also help, in turn, keep humidity, keep moisture inside of these central regions, okay? Further, edge habitat is also a great buffer for fire. Say there is a farm over here, we'll draw actually a big green tractor. Gotta get that John Deere. I grew up in Texas, so tractors are kind of second nature, although all of the ones I know are red. Anyways, say there's an agricultural field here. Some fire breaks out because the farmer was smoking a cig while doing it. Riding out on his big green tractor, threw it out. I'm stereotyping farmers right now. Not trying to do that, but hey, whatever. There's a fire now. Well, usually that edge habitat, in the case of like forested systems, these squiggles represent fire. The edge habitat will actually buffer out the fire. Okay, so there's just two little examples. So wind, microclimates, as well as forest fire buffering. The edge habitat will protect the interior from being completely burned because of, that's just how edge habitat can work. But whenever we have more edge habitat, we actually have greater chances for invasive species. Okay, we actually have, let me add invasive here, and we can also have more mosquitoes and pest species on edge habitat. I just want you to have a brief understanding of edge habitat. In most cases, the edge habitat is not inherently bad, but when we have too much edge habitat, what we lose is this central habitat. So how are we actually increasing edge habitat? How is that occurring? So say we have this beautiful property, this beautiful land right here. It's great, it's big, it can house many, many species. And then we're just gonna build a road right through it, okay? Well, what happens to this habitat? What was once a giant swath a swath, a giant piece, a giant parcel of good internal habitat is now bifurcated by a road. And what happens is around that road is more edge habitat. Okay, so let's draw this in here. So remember, inside of the blue circle is good habitat. Maybe not good is the right way because all habitat is good habitat. But inside of this now, we have, remember, edge habitats can go up to 100 meters into the forest. So now we have this increase of edge habitat. Okay, and this now increases all of the negative effects of the edge habitat. Okay, and we can do the same on the other side, as well as decreasing the availability for this internal habitat. Okay, this internal habitat that is unfortunately required for many species to exist. Not all species can exist in the edge habitat areas, okay? Think of big enigmatic species like bears and cougars. They typically need these large areas of undisturbed habitat. They are not as adept at surviving inside of edge habitat. While other species, say coyotes are a good example of ones that can exist around edge habitat pretty readily, but also other invasive species and generally smaller species. So what we've done is we have dramatically decreased the amount of internal habitat just by building a road, even if there is still forest going around the edges of the road. So even if there is forest here, that would now be considered edge habitat, okay? And these internal areas are now more degraded. And of course, the smaller the land is, the more of an effect it can have. So this is a major problem that is occurring throughout pretty much the entire world. Anytime a road is being built, you are bifurcating large portions of habitat and increasing the amount of edge habitat. So where does wildlife play into this? Well, in the US alone, okay, just in the United States, there are 1 to 2 million collisions between motorists and wildlife every single year. And this has dramatic impacts on wildlife as well as humans. This has resulted in nearly 26,000 human injuries every year, as well as 200 human fatalities every year. And in fact, estimates put the annual cost to Americans at $8 billion. So I just want to frame all of this in mind. In fact, we'll actually write out all of this. So we have 26,000 injuries. We have 200 fatalities. And we have about $8 billion with a B dollars of damages that the U.S. pays out. So this would be cleanup crews. This would be actual damage to the vehicles. This would be any type of law enforcement that needs to get out there, or in the case of like the car hitting the deer and going way off in the road, hitting a tree, causing a wildfire, et cetera, et cetera. So there's a lot of costs that occur from this. But what if I told you there was a way to reduce those collisions by up to 97%? Now we're getting into the crux of the issue. We can create wildlife crossings and enable habitat corridors. So when we say wildlife crossings, one of the best examples, or maybe a classical example, is this. A large, very wide bridge that goes over the road. The bridge is not meant for people. It's not meant for humans traveling across the highway. This is meant for animals. And animals can cross across the highway. So this is an example of wildlife crossings. And there are many different types. But what they are looking to do is enable habitat corridors. So let's break that down a little bit, because sometimes the terms get a little bit jumbled. So whenever we are talking about habitat corridors, what we are talking about are ways to connect habitats. So say we have one piece of forest here and then another piece of forest here. what we would want is some corridor that can connect the two. Now, these corridors can be any number of different things. This could be a piece of habitat. Most often in urbanized settings, these corridors are green belts that follow rivers between the two habitats. This is a very common type of habitat corridor. Another would be canyons. That's another really common way to actually connect it. So make sure that your canyons are connecting large open spaces. And I have a great example of trying to build habitat corridors in an urbanized setting. That's actually my home, San Diego. San Diego has actually been trying to connect all of their various parks together. And they have an amazing interactive map showing all of their parks. So you can see that there are many connections between these habitats. So for example, here is, I believe this is Marion Bear, possibly part of Rose Canyon, up in the north. Right down here is Tecolote Canyon, and they are trying to connect the two via corridors, via habitat corridors, and some talks about wildlife crossings. So here is a really good example of a habitat corridor. So you have the beach over here, you have the ocean. Naturally, you have the Pacific Ocean here. You do have this little, what is this? Does it tell me? I forget the name of this area, but I go there a lot. It's a really cool area to go photograph birds. And if we follow this little green snaky path, okay, again, following a river, I believe this is the San Diego River, this is a green belt. And it's called a belt because it's long, it's skinny, and it is following that river, and wildlife can cross it. Yeah, San Diego River. Then it diverts upwards. We find it hitting out into another park before ultimately connecting to Mission Trails, one of the largest parks that we have in San Diego County. So this is a great example of habitat corridors as well as a few wildlife crossings. So, how do wildlife crossings differ then from habitat corridors? Well, in this case, we talked about habitat that is connecting two habitats. But say we have those same two plots of land, so we have these two forests, whatever, and they are bifurcated by a road. Okay, so a road is going right between them. A wildlife crossing is not necessarily going to be habitat, but it will cross that road, thus being part of the larger habitat corridor that is going on here. Maybe there's some habitat that they want to connect between here, but this right here is simply a crossing, okay? This is just a man-made structure that is specifically designed to cross typically another man-made feature, most often a road. But there are many different types of wildlife crossings. So, of course, we talk about the bridge. And Banff up in Canada actually has some of the best examples of wildlife crossings. They've been doing it for decades, so there's also great data on the effects of creating these different habitat crossings. And this one up at the top, this is a wildlife corridor. This is a highway overpass. You can see that it is typically planted. This is to make it more natural for the organisms, but you can tell very quickly that this is not a big forested area. And here, this picture, actually, I should have shown this earlier. This is a great example of edge habitat, okay? You see along the highway that it's cleared up. That is edge habitat. And going into the woods, up until about 100 meters, the woods around the highways are fundamentally different. They are more affected by wind, they are more affected by water loss, and they typically have a greater preponderance for invasive species. I think I just made up a word. I don't think preponderance is a word. Don't repeat that. Yeah, my auto caption thing is not even picking that up as a word. But there are other wildlife crossings, such as underpasses, ones that go underneath the highway. This is a great example. Road culverts are natural underpass, maybe not natural since we built them, but they are a common artificial underpass that is typically for water to move through, but wildlife do use underpasses quite a bit. This is another example of the overpass, just a good clear picture. There are some trees, but again, it's not fully there yet. But what's cool is that a large amount of species will use this underpasses, these overpasses. Where am I going? Oh my gosh, I'm trying to go here to my whiteboard. And. What was I going to say? What was I going to say? Oh, yeah, these underpasses. I'm looking at my script, which is a loose collection of things. What they have found is we know that these overpasses cost money, right? They absolutely cost money to make. You can't just go out there and build a bridge over several highways without it costing an enormous amount of money. But what they are finding is that there are annual benefits from creating these wildlife crossings, okay? And different studies have shown that the annual benefits from these reduced wildlife animal collisions, wildlife vehicle collisions alone, exceed $200,000 per mile per year. Okay? So think about that. For every mile that you are accounting for, that includes wildlife crossing, that because around a buffer zone, say there's a road here, and you place a wildlife crossing across it here, stretching out, I actually don't have the numbers, but oh my gosh, I don't have the numbers in front of me, but for every mile that this bridge can affect, it's going to save about $200,000 per mile. And I will say, with these wildlife crossings, there's a warming up time. Species need time to adjust. They need to learn. Time to learn. They need to learn that this, that's a B, time to learn. So species do need time to learn these wildlife crossings. I'm covering up the exact thing I just wrote. So they need time to learn. It does cost money. And there is a little bit of a counter argument in that you have to build fences. So essentially, we can actually show you a real world example. In many cases, you have to build some type of fence. I believe where is it? This one here shows it well. Yeah, it's a little bit hard to tell in this video. I can actually zoom in for you guys. Boop, boop, boo. Here we go. So if you look around the edges of the highway, you'll see a very long fence going along the highway. And this is to essentially funnel the species over the crossing, okay? It's going, say a deer, a moose, an elk, or whatever, is going to run into this fence. Usually it's not going to hop it. It's not going to hop it too crazy much, but it's going to walk along it. It's going to find the crossing, and then it's going to go over it. Eventually what they find is the animals actually know where the crossing is. It's a learned behavior. They know it's a safe crossing to where they don't have to get hit by a car just to get to the other side of the habitat. And what they find is that with this money that is being saved, it is actually beneficial cost-wise to do something. It is actually, it actually costs society less to solve the problem of wildlife vehicle collisions than it costs to do nothing. So that $1 billion a year just in the US, imagine if that money, or $8 billion a year, $8 billion a year of costs were funneled into creating wildlife crossings. That is going to save society as a whole money in the long run. So naturally the question is, why don't we have these crossings? Well, the paper that I was talking about here, this large document here, let me make sure I'm small again, actually details out some of the major issues. And one of the biggest problems is that there are often many organizations that are operating the roads, the parks, and they all have a vested interest. So say we're in the national forest. So let's just say we have a forest here, and this is managed by U.S. Forest Service. You have another plot of land here, also managed by U.S. Forest Service. And then maybe you have an adjoining plot that is largely managed by Fish and Wildlife. So Fish and Wildlife, and then you have this road coming through here, but then you find out that the road up until this point, this is managed by the county, But then this part of the road is managed by the state. This actually does happen quite a bit. I remember when I lived in College Station, they were actually trying to build an overpass for people to get from the bar to the classes. And it was such a terrible problem because the road, they were disagreeing on whether it is owned by the county, owned by the city, and who would actually front the cost to build that overpass for the people. And then, even if many times there is federal funding to build these overpasses, okay? So there's federal dollars, big dollars to say, hey, we are the federal blah, blah, blah. We are partnering with Fish and Wildlife and U.S. Forest Service to build this overpass. Awesome. They front the money to build the overpass. But then, who handles the maintenance of that overpass? Who has the crews going out there to make sure the bridge is structurally sound, to make sure if a car crashes into it that they can repair it? Who is in charge of that funds? It's not the federal government in a lot of cases. It's not them. It's actually going to be the county. It's going to be the state. This should be a check mark. It's going to be the county. It's going to be the state. So whenever they're saying, hey, we want to build this money, the county could be really realistically and very honestly saying, we don't have the money in our budget to maintain this long term, so we don't want to work on this. Or it might just be the fact that U.S. Forest Service, Fish and Wildlife, they want to collab, they want to put this together, but then they have different goals. They have different ways of doing things. They have different funding opportunities for that fiscal year. So it really is just, like, for lack of a better word, it's just kind of a clusterfuck to figure out, how do we build this bridge? How do we maintain it long term? Not to say it can't be done. Many places have done it. It just requires a lot of moving parts to even build something very simple. Or even just converting an already established culvert into a underpass, another wildlife crossing. In order to properly have it act as a wildlife crossing, you're going to have to pay for the fences. You're going to have to pay for the monitoring to see what species are going underneath it. You're going to have to pay for the biologists to go out there and analyze the data. And in some cases, it can take taxa several years to figure out exactly how to use these crossings. So all in all, it is just a little bit more of a complicated problem. I know many people, myself included, have said, like, why don't they just build it? It's not that big a deal. It saves them money. And often, like many things in biology, it is bureaucracy, it is politics, and it is just, we have the money, but could someone else pay for it instead? So, yeah, but this is a very brief overview. I tried to keep it brief. I'm looking at the time. It's right now 23 minutes. So, yeah. But let me know your thoughts. If you've watched till the end of this video, you're a BAMF. I appreciate you. I'm still trying to get these videos out, hopefully almost every day. I want to be able to get to 3 times a week at the very, very minimum. So I'm just trying to figure out how better to do that. Even if this video is not perfect, I don't care, because I just want to get it out there. And if 90% of my information is spot on, then I'm happy at this point. So I'm rambling. I don't want to hit it 25 minutes. Hope you have a great day. And if you like what I'm doing, please give me suggestions. Please give me ideas of what to talk about. And yeah, subscribe. Do that thing that YouTubers tell you to do. What's up? See ya.